take the case where there is a wheel which is rotating about axis O. This wheel is fixed on a mount. This mount is stationary and this wheel is rotating with angular velocity omega. So we know V is equal to r omega. So velocity of this point is going to be equal to r omega in this direction. Of this r omega in this direction, if this is rotating with angular velocity omega in the clockwise direction, this point velocity r omega, this point velocity r omega. And let's place a person over here at the axial, be it axial or be it mount, it doesn't matter. So this person is sitting over here at the axial. So this person sees the velocity of this as r omega, velocity of this as r omega, this velocity as r omega, this velocity as r omega. Similarly, when this mount is fixed, then this person on ground, this is the person on the ground, either you say velocity with respect to ground or as seen by a person on the ground is one and same thing. So this person will also see the velocity of this as r omega in this direction, velocity of this as r omega in this direction, velocity of this as r omega in this direction, and velocity of this as r omega in this direction. When this mount is stationary, then the velocities of these particles seen either by this person on the axial or the mount is same as that the velocity which are seen by this person on the ground. Now what happens that this mount also starts moving in this direction with the velocity v. So now we are interested in finding, that is, what are the velocities which are now going to be observed by these two persons separately. That is, what are the velocities this person will see of these points and what are the velocities of these points with respect to the person on the ground. When this starts moving in this direction, the velocities of these points will remain same as with respect to this point. But with respect to this, if we have to find the velocity, let's say, of this point A. So how do we find the velocity of point A with respect to the person on the ground? We can use triangle law of vector addition. That is, if you have to find the velocity of point A with respect to person on the ground, it is the velocity of this person with respect to person on the ground plus velocity of this point A with respect to person on the wheel or person on the axle or person on the mount. So velocity of A is going to be equal to r omega plus v. That is, this is going to be r omega plus v, and this is going to be r omega in this direction, v is going to be in this direction, that is, superimpose the velocity of this in this direction. It is r omega because of its rotation and v is because the whole thing is moving in this direction. So the v velocity has also been added in this direction in simple terms. Similarly, r omega is in this direction because of rotation and v is the velocity because of translation of the whole thing over here. Similarly, r omega is because of rotation over here in this direction, and because the whole mount is given a velocity in this direction, it means that this also has a linear velocity in this direction, and we can find the net velocity as vector sum of these two velocities. On the same lines, we can even find the acceleration also. If this is rotating with omega, we know centripetal acceleration is v square upon r. Now v is equal to r omega. So r omega square upon r comes out to be r omega square. So if this is rotating with angular velocity omega, so this point has acceleration, that is centripetal acceleration, as r omega square in this direction. This point has r omega square in this direction. This has r omega square in this direction, and this has r omega square in this direction. Even for this particle also, it is r omega square in this direction. So over here we have taken a case of when the body is moving with a uniform angular velocity. What if this body is not moving with uniform angular velocity and we have some alpha also? If we have some alpha, it means that is, this is non-uniform circular motion. If this is non-uniform circular motion, it means we are going to have a tangential acceleration also. And we remember from understanding of our circular motion in the lecture what we did in circular motion, that is A tangential is equal to r alpha. Suppose now at this instance it also has a alpha also. So it means A is equal to r alpha is in this direction, there is other acceleration. So tangential acceleration, A is equal to r alpha in this direction, A is equal to r alpha in this direction, A is equal to r alpha in this direction. So net acceleration, if someone asks, it is a vector sum of these two over here. Similarly of this is this side, this is this side, we can find the net acceleration in this direction. For all the points we can find the net acceleration, because this is a non-uniform circular motion. We know in non-uniform circular motion there is going to be centripetal acceleration also and there is going to be tangential acceleration also, and the net acceleration is vector sum of these two acceleration, that is tangential acceleration and centripetal acceleration. Now what if this mount also starts moving in this direction with A. So now what happens is, that is, in addition to these all the accelerations, we add one more acceleration. That is, this will be there, this will be there. In addition to this, A will also get added up. A will also get added up. If this whole mount is moving in this direction with A, or if we say that is a wheel is rotating about this axis with angular velocity omega and alpha, and this is also accelerating this way, so the net acceleration is going to be, we add this acceleration as A, so this is also going to be A, and this is also going to be A. So we can find the net acceleration of all the points.